Okay, pause and copy, pause and copy, pause and copy. Now, test for divergence. So we're going to look at a few more tests for deciding whether a given series is convergent or divergent. That's our main approach here. You don't want to figure out the actual sum. Usually that question is much too hard. So what we'll be doing is just determining whether a given series is convergent or divergent. Okay, our first test is the test for divergence. It's saying that if your limit of this sequence is not zero, then there is no hope for this series to converge. Well, think about what we're talking about here. You have an infinite series. You're adding up an infinity of terms. Now, if they individually are not getting smaller, if these terms are not getting smaller and smaller, how can you hope for the overall sum to actually equal a real number? Well, you cannot hope. That's what the theorem is saying. If the limit doesn't exist, that'll also imply divergence. An example being if you have summation -1 to the n. So an is this alternating thing. And what this thing is doing is going -1 + 1, -1 + 1, -1 + 1, -1 + 1, -1 + 1, -1 + 1, -1 + 1, forever. So it does not approach any real number. Okay, so in that case, the corresponding series is going to diverge as well. Okay, so let's apply this. Pausing for a second to make note of part 2 here. Okay, if you get limit of an is 0, then that tells you absolutely nothing. So you are in a sad face situation. Maybe I should. No information, sad face. Okay, let's try this example. An is equal to the corresponding sequence. So you just drop the sigma. So for the limit, you just need to focus on the dominant terms in the numerator and denominator. So limit an is going to be the same as limit -20 n cubed over 12 n cubed. So you can reduce that fraction to get -5 over 3. So I did not get 0. That's not 0. Therefore, the corresponding series is divergent. And we'll say by test for divergence. Okay, it's a little bit confusing. The sequence here, an, the sequence is convergent. It converges to -5 over 3. Okay, but when you talk about the corresponding series, which is a different thing entirely, it is divergent. Okay, so be careful to separate the sequence from the corresponding series. Okay, in one case, you are adding things up. In the other case, you are just putting a comma between terms. Okay, I've just realized that 11.4 is our last section in the textbook. Well, I've had a good time. I hope you have too. I think you guys are pretty cool. I'm certainly cool. I am certainly cool. No doubt about that. Is it? It's good? Okay. My method on the microphone is banging. Wu-Tang Clan will leave your headpiece hanging.